You can tie your local date time objects to time zones, and that is done with a class called zoned date time. To do that, you first need to find out which time zone you need to use. And that's done with zone ID. Zone ID can be specified in different ways. You can use zone IDs as UTC offsets. You can use zone IDs as GMT offset. You can do the zone IDs by name. You can do the zone IDs by region and city, whichever way. Yes, so you can identify the zone in whichever way you feel convenient. So in this particular case, I'm identifying a couple of time zones, one in London, one in LA, California. And then I'm setting up here a local daytime object, a certain date and time. And then I'm saying what would be the zoned date time for that if I consider that this local date and time is associated with London. So I've got local date time, I'm saying, okay, let it be local in London. And then here's an interesting method with zone same instant. This method answers me the question, what time and date would that particular time in London, which is what I've just constructed, what that would be in LA. So it calculates that and actually takes into account things like, calendars, daylight saving times, international time, date boundaries, and all that. Yeah. So it calculates that for you. Pretty straightforward. Okay. Now, the last topic in this lesson will be dedicated to the question of localization. And the reason why we need to talk about that is because we've already mentioned that we need to be able to convert between, say, numbers and strings and dates. And often these text to number, text to date, or vice versa conversions require you to consider differences in locales, in the fact that different languages and different countries present dates and numbers as text in different ways. By default, when you deal, for example, with local date time or zone date time, by default, Java will assume that you use an ISO calendar, an ISO date representation, which is year, month, date, hours, minutes, seconds. But if you want more specific country-specific or language-specific representation for a date or a number, well, you could do that, but you have to specify which country, language, whatever you would like to use. And for that, you use the class locale. Locale could be initialized with just language, so FR for French, yeah. It could be initialized with country and language, ENGB or ENUS. You can also have custom variants like, just I have some customization I'd like to apply to standard localization. You can also use designated codes for territories. So sometimes you deal with a region like Caribbean, for example, isn't exactly a country, but rather a region. So if you want to say French Caribbean, then that's how you do it here, qualify the region. There's another way of creating instances of locale. So yeah, you can get current machine default. It's as simple as that, just get default. But there's another one, it's called for language tag, locale for language tag. And that allows you to specify language, country, but then it allows you to go nitty-gritty with that locale. You could say, I would like a Buddhist calendar. I would like to use Thai, the THS of Thailand, Thai in representation of numbers, which is not exactly the same as European. So you have to sometimes consider these, localizations. They might be important. Maybe your users are using different ways of presenting numbers. Maybe you're using different calendar. So to handle correctly that input and output interactions with users, you may have to qualify that level of detail. Okay, so locale represents whatever country and language you need. Now, how do you use a locale? Well, let's assume the following scenario. let's imagine I've got some numbers and dates and whatever I need. Yeah, so first this page looks at numbers, there will be a later page looking at dates. The numbers here are represented using big decimal, using double class, that's a wrapper class, and using an int, which is a primitive. Why these three? Just to show you that the approach that you apply to wrappers, primitives, and big decimals is exactly the same. That's the only reason why we have three variables, just to demonstrate that it's the exact same approach. But also we'll do different formattings on them, just apply different format. So we then initialize the locale, in this case ENGB, that's British English. And then we create, use a number format class, Java text number format, use a number format, we create instances of currency, percentage, and general number representation. So that answers the question, what is the format for British English for currency? What's the format for percentage? What's the format for general number? And then using these formatters, you call the method format and you pass whatever big decimals, wrappers, primitives, whatever you need, you pass to the as an argument to the format method, and that gets you a string result formatted according to that country and language locale, whatever you need it to do. The other way around, the opposite direction of conversion, is when you need to convert some text values into numeric values. In this example, suppose user enters some text like pound symbol 1.7, so that's some kind of British currency amount. So the user typed that, and then you need to present it, let's say as big decimal. So what do you do? Well, first you call parse method. Parse method accepts a string and returns you a number object. There is actually a class called number, which is the parent class of big decimal and all the numeric wrappers. But we'll study the class hierarchy later in this course. For now, basically what you need to understand is you need to convert that number to whichever specific type you like it to be presented as. Do you want it to be presented as big decimal or as double or maybe some kind of primitive, whatever you like. So when you call the parse method, first you get this general representation of the number, and then you're deciding what specific way of representing in your program that number you want to achieve. First example here returns the value eventually as big decimal. The second example parses percentage and returns it a double, and the last one represents the value as just a simple int. With date and time parsing and formatting, you got very similar approach. Use Java time format, date time formatter class, which allows you to construct the formatting pattern, either using a style which is default style for a certain locale or specific pattern that you want to construct. In this particular case, we've got some local date object. We initialize the locale as British English, and we create a format object, which will be of a certain pattern. And this pattern takes the day of the week, the day of the month name, and then the year, and formats it according to the British English locale. So you take date format, and the method is called format, and I just call that variable format as well, but you can call it whatever you like. The other way around, you can do the parsing. So the user types some text, and then you can parse it as the local date with that format object in mind. Now you can switch the locale, you can reinitialize locale to something else. So in this particular case, RU, that's for Russian. And we use the same date time formatter, but this time we reinitialize in that date time formatter to use the format style medium. We're not qualifying specific format mask. Instead, we're saying whatever is the default medium format for that particular locale. So it could be short, medium, full, so different styles in which the date is or time is represented in a given locale. And again, we're calling the format operation here, and that is the result on this occasion, right? So we're parsing and we're formatting using different locales. Okay, well, Then we need to decide what do we do with all other localizable resources, because we have to deal not just with dates, times, and numbers, but with any other text that we may show to the user, or, accept from the user. So all these different sort of text values, they might have to be translated into different languages and handled differently depending on the locale that the user prefers to use. To do that, we can produce resource bundles. Resource bundles could be produced as just plain text files, .property files. Actually, you can create them as classes as well. And there are some examples you could find in notes, but generally it's just property file with the name value, key value pairs, key value storage. So here's some examples of these property files. Let's say, for example, we created a file called messages, and called messages.properties, and then we can create copies of that file per locale that would like to use. So it could be specific to particular countries, languages, whatever. And in each one of these copies, we have same keys, but basically different values. So we translate values to different languages. The default bundle, the one with no country and language in it, doesn't have to be English. It's entirely up to you. In this particular case, actually happens to be Japanese. So we got a few different resource bundles. Now, what's in a bundle is key value pairs, as you can see, but the values can have this substitution positions. So apparently you can treat them as kind of text patterns into which you can then substitute, real values from your program. Now, how do you get a bundle? So first of all, you create this messages file, and imagine you've put it in a folder which is one of your Java packages. So suppose resources is some kind of package. So then you create a locale object, and then you say, and I'd like to get my bundle, and you use the folder, which is the package name, and then you use a file name, but no .properties, just that, and which locale would you like to use. That gets you an appropriate bundle. And then you can get values from the bundle using the getString method, specifying different keys. So it gets you this hello and then gets you the other. Notice that a certain key value pair may not be present in all the bundles. So that means when you're trying to load, say, for example, ENGB bundle, and there is no key other there, then it will be picked up from default bundle. Right? So watch out for that. You can get strange mixes of locales that way. Okay, so that's how you load the bundle. Now, what do you do with these texts once you get them? So there's these patterns, that were retrieved from the bundle that may contain just text or may contain text with some substitution characters, substitution positions. Well, you can substitute values, right? So how do you do that? That's done with a message format class. So the idea is that if I retrieve from the bundle a message like this, there's a key product, there's a message which is some kind of, I guess it's an information about a product, name, price, quantity, best before, with these substitution positions. So I get that from the bundle. Assume you already formatted all the prices and quantities and dates, just like you've seen on earlier pages. Assume that's done, you've got formatted texts, that's fine. Now, what do? You get that key from the bundle, get that pattern, So the key product yields you that pattern. That's that string. And then you use the method format, and you say you want to use that pattern, and then simply enlist all values you want to put inside that pattern in the same order as these positions. So name goes on position 0, price goes on position 1, quantity goes on position 2, best before goes on position 3, and that's the formatted result. Well, assuming you all previously formatted all the dates and numbers. To summarize this chunk of the lesson, we have this page. This is just a summary, basically. This page tells us that if you want to do correct localization of the application, you consider creating resource bundles, translating them to whatever languages you need. And actually, if you don't want to do the localization, it's worth creating resource bundle, default bundle anyway, because you then would pick up values you need from the bundle rather than hard code them into the program. If you need to change a prompt somewhere, you don't want to recompile your Java classes every time. You can just fix the text in the bundle. That's much easier than going about a source code and messing about it every time. So anyway, you create a bundle, you translate it to other languages if you want, or just default bundle. Imagine you have certain values, like maybe some numbers and dates, yeah, and pieces of text. So you initialize the locale, you get the bundle, then you do all the format initializations. So in this particular case, I qualify that I would like to use certain date pattern. I would like to use certain locales for currencies and number instances. And then I do all the formattings. With the date format, actually, there are two ways of doing it. You can say you'd like to use date formatter class and call method format and pass date as an argument, or the other way around. You can take date and call method format and pass date formatter as an argument. It's entirely up to you. There is no difference whatsoever. Just two different styles of achieving exactly the same result. And then we get the message from the bundle. And then we substitute into that message pattern whatever values we've previously formatted. There you go. Yeah, so that's the formatted result. This is just a summary of what you've seen on this segment of the lesson, which basically summarizes all this text to number to date and vice versa conversions. Okay. So that is it for this lesson. We started by just discussing how text is represented in Java, and it's either as a mutable string or mutable string builder for more complex text manipulations. Then we looked at all sorts of primitive wrappers, the way we can bring in object-oriented behaviors to primitives, so we can operate on them with methods. And we then looked at a big decimal class, which is designed specifically for decimal math, and which is jolly useful if you want to represent things like fiscal values, which are presumably decimal. And it can use arbitrary precision, which is also very useful. And then you could represent dates and times and periods and durations and instants and manipulate with these, and even go as advanced as time zones. And then eventually we just discuss how do we perform correct handling of text to number, date, and vice versa conversions with respect to different locales. And also, whilst we're at it, we were saying, well, if you localize in the application, you need resource bundles. And actually, it's a good practice to put resource bundles anyway, and not to hard code text of the program as such. So, practical exercise for this lesson continues to manipulate with these values using JShell. So you're manipulating with some text, and you use a string builder, and you also manipulate with numbers, dates, and times, and you apply localization and do some formatting of values as well.